Hello everyone, my name is Rahul and I am going to present a seminar on electronic textile. So let's get started. So first of all, the introduction. So electronic textile or e-textile are the fabrics that enable digital components such as battery and a light and electronics to be embedded in them. Basically, it's saying that the electronics textile is a combination of microelectronics and textiles. Smart textiles are the fabrics that have been developed with new technologies that provide added value to the wearer. Smart fabrics are revolutionary because they have the ability to do many things that traditional fabrics can't, including communicate, transform, conduct energy, and even grow. So, smart fabrics can do many things which our traditional fabrics, clothes like these, can't do, like communication, transform energy from environment. So this is the process through which these smart fabrics are made. So first of all, we take a emulsion polymer, then a porous textile substrate. This emulsion polymer is printed over this porous textile substrate, and reduced graphene oxide is now printed on this, which is a combination of emulsion polymer and porous textile substrate. Through this process we get a smart textile. So here we can see it has a heart rate monitoring. So now let's talk about its categories. Smart textiles can be broken down into two categories: aesthetic, performance enhancing. So first of all, let's talk about the aesthetic. So aesthetic fabrics are the one which can change its light, and fabrics that can change color. So some of these fabrics gather energy from environment by harnessing vibrations, sound or heat, reacting to these inputs. The color changing and lighting scheme can also work by embedding the fabric with electronics that can power it. So basically it's changing its color, or it's giving us light. So we need some source of energy to light this fabric. So we use external electronics component like batteries, power banks, etc. Now let's talk about the performance enhancing. So as the name suggests, performance enhancing, so these fabrics are used to enhance the performance of athletes, military personals. So let's read this. Performance enhancing smart textiles are intended for the use in athletic, extreme sports and military applications. These include fabrics designed to regulate body temperature, reduced wind resistance and control muscle vibration. So these fabrics actually enhance our performance by controlling muscle vibrations, regulating the body temperature. So it can heat up or cool down according to the body. Other fabrics that have been developed for protective clothing to guard against extreme environmental hazards such as radiation and the effects of space travel. The health and the beauty industry is also taking advantage of these innovations. So the health and the beauty industry is also using this emerging technology, which range from drug releasing medical textiles to fabric with moisturizers, perfume and anti-aging properties. Many smart clothing, wearable technology and wearable computing projects involve the use of e-textiles. Now let's talk about the sensors. So these are the textile electrodes. These are the sensors which collect the data from the body and transmit it to a laptop or a smartphone by ZVIC wireless communication. So let's see this. Smart textiles fabric can be made from materials ranging from traditional cotton, polyester and nylon to advanced Kevlar with integrated functionalities. At present, however, fabrics with electrical conductivity are of interest. So it says that the smart textile can be made of anything like cotton, polyester and nylon. But nowadays we are actually interested in the electrical conductivity of the fiber. electrical conductivity fabrics that have been produced by deposition of metal nanoparticles around the woven fibers and fabrics. The resulting metallic fabrics are conductive, hydrophilic, and have high electroactive surface areas. These properties render them ideal substrate for electrochemical biosensing, which has been demonstrated with the detection of DNA and proteins. There are two kinds of smart textile products that have been developed and studied for health monitoring. Basically, there are two types of smart textiles for health monitoring: fabric with textile based sensor electronics and fabric that involves traditional sensor electronics. It has shown that the weaving can be used to incorporate electrically conductive yarn into a fabric to obtain a textile that can be used as a wearable motherboard. It can connect multiple sensors on the body, such as we get gel ECG electrodes to signal the acquisition electronics. Now these are the sensors continued. Later research has shown that the conductive yarns can be instrumental in fabrication of textile based sensor made of fabric or metallic meshes coated with let me change the slide. Sorry for the interruption. So let me read this point again. Later research has shown that conductive yarns can be instrumental in fabrication of textile based sensor made of fabric or metallic meshes coated with silver or conductive metal cores woven into fabric. So let's see this picture, and here we can see that there are various electrodes which collect the data from the body and send it to a application in a smartphone or a laptop to actually read the data. There are two broad approaches to fabrication of garments with ECG sensors: electrode in research, finished garments through functionalization or integration of finished garments with sensor elements. This approach involves the integration of finished electrodes into finished garments by simply stitching the electrodes at the appropriate locations on the garments or using deposition techniques to transfer the functional materials at the appropriate location. Now let's talk about these unfinished garments. The introduction of smart materials during the garment fabrication process. This is unfinished approach entails the use of textile fabrication techniques to form woven or non-woven fabrics with the inclusion of functional materials. So let's talk about its benefits. So first of all, let's read this. Electronic textile or e-textile are the new emerging interdisciplinary field of research. Well, it's a new technology and it's emerging day by day. Now we are able to see bags which can actually show emojis and anything which you actually draw on your mobile phone, and it's connected with a application, bringing together specialists in information technology, microsystems, material and textiles. E-textile offer the following advantages: flexible. Well, textiles are always flexible, and no wires to snag environment. Actually, there are no wires to pollute the environment. Large surface area for sensing, because it covers your back and the chest area, so it's very large surface area for sensing. Invisible to others, like it's just like you are wearing a t-shirt or something and it's invisible to others. Cheap manufacturing. Now the benefits continued. The focus of this new area is on developing the enabling technologies and fabrication techniques for the economical manufacture of large area, flexible, conformal information systems that are expected to have unique applications for both the consumer electronics and aerospace military industries. They are naturally of particular interest in wearable computing, where they provide lightweight, flexible computing resources that are easily integrated or shaped into clothing. Let's talk about its limitations. So first of all, it has a limited reliability because we can't wear it on a rainy day. It's not weatherproof or windproof. Limitation concerning mass production. It can't be mass produced because it's hard to create a smart textile. Limited processing and storage capability. It has a limited processing and storage capability because the particles used are very small. Limited power supply. The power supply is only limited to a external supply. Specific range of application, not as flexible as textile clothing. So it's not as flexible as textile clothing. Now let's talk about its future. So in future it can be a weatherproof and waterproof systems. We can make weatherproof systems and waterproof systems so that we can wear it on any day and making it more reliable. Wireless transmitters that can collect data even outside 4G areas. Smart textiles for all children. Commercialization so that everyone can have a smart textile. Automatic calibration. Data can be sent to doctor by a phone application or tablet application. The doctors can collect data in real time. So this will help the health industry very much. It will appear as a boon for them because they can collect data from in real time from a very long places. Integration of other fabric materials that can help improve versatility. Yarn spandex material for exercise clothing. Now the conclusion. So basically, as I said earlier, electronic textile is a result of combination of microelectronics with textile, result of convergence of microelectronics with textile, and surrounding us in our daily life. Well, it has come that it has surrounded us in our daily life. We can see bags which are electronic, and which we can see what we can say that textiles, clothing, t-shirts, etc. used in clothing, home textile, military, navy, medical application. Limited reliability. Nowadays it has a limited reliability and high cost. Specific range of applications, not as flexible as textile clothing. Now these are the references from where I have prepared this seminar, and let's see this image. So here in image we can see there are two athletes who are wearing smart fabrics. So we can collect the data in real time from these smart textiles. Thank you. I hope that you are enjoying your quarantine period.